Hello everybody, and in today's class we are going to do some mesh and node analysis. Basically, we are going to use the Ohm's law, KVL and KCL in solving some simple circuits. Okay. So it is a kind of tutorial today. We are going to not read too much of a theory, but we are going to try and solve some examples and try to find a solution to some of the problems. Okay. Before that, let's define what a mesh is and what a mesh analysis means. Okay. See, we studied about what is loop. In the last class. It is a closed path with no node passed more than once, right? A mesh is a loop that does not contain any other loop within it. Okay. If I give an example, the one which is shown in black dotted line out here, from a voltage source, you have two resistance in series in the horizontal, horizontally placed horizontally, then you have one vertical resistance, then one more horizontal and coming back. So you have this black dot. So that is a loop. Okay. But that fits in the definition of the loop, but that is not called a mesh. Okay. Whereas this small one within inside one, that is called a mesh. Okay. So a mesh is a loop that does not contain any other loop within it. How we are going to solve problems is we got to identify the meshes what are there in the circuit and then apply KVL. So that is how we are going to solve these networks. Okay. So we are not going to apply KVL across the bigger loops. We are only going to focus on first to try and apply KVL in the mesh and then try to solve it. Okay. So this is how, these are the steps which has been listed out. Identify the M meshes in the circuit, assign a current to each mesh, right? So in each mesh there will be a current, so we need to assign current to each of these mesh, assign voltages to the elements for which no voltage is designated. If there is only some resistance is given there or then we need to just assign some voltage for that and try to find out the voltage by solving the various equations which we get. Apply KVL to these meshes and use Ohm's law to express voltages across resistors and solve the resulting M simultaneous equations for mesh currents. Okay, so these are the steps which has been listed out. It will be pretty clear once we solve the problems. So in the mesh analysis, essentially we are going to use Ohm's law and KVL. These are the two laws which we are going to use, and subsequently we will see node analysis in which we will apply KCL. Okay. Now this is the first example where you have a battery of 28 volt, 4 ohms, 2 ohms and 1 ohms, and then you have an 7 ohms. So you need to there are two mesh out here. Now we are going to apply first we need to assign some currents in the mesh. Okay. Here I have taken one current as clockwise, the other one as anti-clockwise. So not necessarily, you can take both the currents to be clockwise also, so it's up to you. Okay, just that when based on the direction which you have assigned, so the equations will be accordingly be framed, and you have to be careful with the polarity. So in this particular case, I have just taken it as clockwise, and here I have taken it anti-clockwise. But finally, it might so happen that the current I2 might be negative, and there could be some current going into this battery. That is also possible because here you can see just by seeing this circuit, I can say that 28 volt battery which is at much higher potential, finally I2 is going to be could be negative here. Okay, so there is a possibility. So nevertheless, I have taken this as an anti-clockwise direction, and this as clockwise direction. So just a starting point, whichever way you get, finally if you are careful with the signs of these currents, then while framing the KVL, then you will get the same answer irrespective of how you start. Okay. Now to write the first equation in this particular mesh, you see 28 volt is available here. Okay, that gets split across 4 ohms and 2 ohms. So the current flowing into the 4 ohms will be I1. whereas what is going to flow into, so the voltage across this will be 4 into I1, whereas what is going to flow in 2 ohms is I1 is going to flow from top to bottom, and I2 is also flowing in this, see, if you see the direction of I2, which is anti-clockwise, so that is also going to flow in the same direction from top to bottom. So the equation would go like this: 28 is equal to 4 I1 plus 2 I1 plus I2, right. So if you just open up these brackets, you get 28 is equal to 6 I1 plus 2 I2. This is the first set of equation, which consists 2 variables I1 and I2, which we got from the first mesh. Is this aspect clear to all of you? Is this much okay with all of you?
Yes, sir.
Yeah. Okay. So you have to be the silly mistakes which we generally make the students in the exams is they mess up with the polarity of the, like you just put one negative out here, whereas we are considering the current like this, then your whole answer goes for a 6. Okay. So just the first framing of the equation, and only there you tend to make mistakes. So be careful with the signs which you put there. Okay. Now if I go to the second mesh, again I have a 7 volt out here, and if you see the current which is going to flow through this 1 ohm, because here only I2 is going to flow in this 1 ohm, so it is going to be I2 plus this is R2. Again the current is going to which is 2 ohms, and the current, both the currents I1 and I2 are going from top to bottom. So you have 2 I1 plus I2. So you write this equation. Now you open up the bracket, you get 7 is equal to 2 I1 plus 3 I2. Now you have two sets of equations, and you solve it. So you get this is normal mathematics, two simultaneous equations where you equate the coefficients of either I1 or I2, and then you subtract it, and then normal, which you all know how to go about it, right. So you get the values of I1 and I2. So if you see here, I2 is negative. Okay, that we guessed it initially itself, because this is at a much higher potential than 7 volts. So obviously current would flow into the battery in this case. So that's how I2 is negative and I1 is positive. So this is how we go about solving these kind of problems. Now coming to nodal analysis, here we are going to use KCL instead of KVL. Here we are each of those nodes we are going to apply KCL, but before that we need to in the circuit anywhere we have to choose a reference node, or we just assume one of the wire sections and one of the nodes is at a ground potential. Okay, so we can use one of these symbols in this. When you draw a circuit, we can put one of they all represent a ground. So we need to assume that one is one of the nodes, which wherever we place one equipotential nodes as ground. Okay, that we can do that. Once we have done that, we apply KCL to each of the nodes, and we get different expressions, and we are going to solve that. So here it is very similar to mesh. Only thing is we are going to use KCL instead of KVL. So let's take an example. So this is an example out here. So if you see, we are going to put a ground out here. Even if this ground is here, in this case the ground is already given, but even if it is not given, we can declare this node as a ground potential. So we put it as ground here. Now there are two nodes out here, so we are going to write KCL at these two nodes and get two equations and try to solve them. So if you write the first one, if you see out here, V1 at this node, if you write the KCL, I1 is flowing into the node, and I3 and I2 are coming out of the node. Okay, so the equation comes out to be I1 is equal to I2 plus I3. Right, and if I write an equation for this node, you see there are two currents which are coming in, I2 and I4, and 5 amperes which is going out, which is again same as I1. right, and then you have I5 which is coming below out here. Excuse me. So so you write these equations, and I2 plus I4, these are the currents coming into the node, and I1 and I5 which are going out of this. Okay. Some I4 is 10 amperes, it is known here, and similarly I1 is 5 amperes. Okay, so that is also known. So after that we need to try and substitute these values out here, right. The first equation we have taken, I1 is equal to I2 plus I3. So I1, that is known as 5 amperes, and then we have to write the other currents in terms of the node voltages. Okay.
Sir, I have a doubt, sir.
Yeah, tell
Sir,
me.
how did I1 come in node 2, sir? There is no current source of I1 near node 2.
Uh,
Sir, at node 2, we only have I2, I5, and I4, right?
I2, no, the upper one, upper branch, this,
Yes, sir, yes, sir, yes, sir.
that is
Yes.
I1, right. Okay, so that is I1. That is 5 ampere. Okay. Now in the first equation, now once we write these two equations, now we are going to put the value, try and put these values of V1, V2 or known factors into these two equations. Then it will become two equations in V1 and V2. Then we solve V1 and V2 and we get all the values. Okay. So there are two equations. We have two nodes, V1 and V2. So, so we are going to write all these currents in terms of V1 and V2, and using these two equations solve for V1 and V2. So the first equation, I1 is 5, so that is evident from this, and that is equal to I2 plus I3. So I2 is nothing but the potential out here is V1, this is V2. So V1 minus V2 by the resistance 4 ohms plus I3. I3 is V1 minus this is ground potential, so it is 0 by 3. So you get 3 V1 minus V2 is equal to 20, right. That is because you have taken LCM here and taken this 4 out here, 4 into 5, 20. So you get an one equation out here. Similarly, in this equation also we are going to substitute the value of V1 and V2 and known variables also. Known variables means I4 is known, and I1 is known. So we are going to put that, and we are going to put I2 and I5 in terms of V1 and V2. So here this is what we did in the last slide. Now here this is the next equation where we are going to substitute. So I2 is V1 minus V2 by 4 plus I4. I4 is this 10 amps which is coming into the node. So these two currents are coming into the node, and then which is leaving the nodes is 5 amperes. That's I1, we are going to replace it with 5 amperes, and this current that is going to be V2 by 6, right. So now you get one more equation. Now solving, now you have two equations which is in V1 and V2, and we solve that, we get V1 and V2, right. And once V1 and V2 is known, you can also put those values and get the values of all other I1 and I4 is known. You can compute the value of I2 and I3 also, right. I5 is just V2 is known, so you can compute V5, and similarly V1, V2 is known, so you can compute the value of I2, V1 minus V2 by 4, and so on and so forth. So this is how we handle nodal analysis. Okay. So now let's take something which is known as super mesh concept. Okay. Here sometimes in circuits you have an current source. It could be an independent current source, or it could be a dependent current source also. So if you have like that, you can't really write an mesh equation, KVL error using where there is a current source. Okay, because if I try to write the equations, say in this mesh, what can I write? V1 plus voltage across IS, which I don't know what is the voltage across an IS, then R1, right, and IS into R1, and then some. So you have something which is not going to be defined easily, so it will become difficult for us to solve these kind of problems where you have an current source in between. It could be a dependent current source or it could be an independent current source, whatever it is. Any current source which is there is likely to not give us a straightforward solution. So in that case, we can use a super mesh. Okay, a super mesh is something like that. We are taking an trying to take a mesh in which we are bypassing the current source. Okay, so that doesn't come into the KVL equation. So we have to take a super mesh, and then to take care of this IS issue also, because finally to get a solution we need to take into consideration the value of IS also. So in that case, like in this case, since we are taking a value of I1 like this, I3 like this, so we need to equate the currents. Okay, in this case if you see I3 is going like this, right? So we need to write the value of IS as I3 minus I1, right? So that is one equation which will take into consideration the value of IS also into the circuit. So that is how. So if you try to solve this, so this is the equation, right? So for the first mesh, so here there is no problem in this mesh, there is no current source, so we can write an equation clearly for this. For KVL we can write straight away one KVL for this mesh. So it is like 1 into I2 I2 minus I1, because there is a current I1 also flowing into this 1 ohm. So it is 1 into I2 minus I1, current in this 1 ohm resistor, right? I1 is flowing from top to bottom, I2 is flowing from bottom to top. So I am writing I2 minus I1, then 2 ohms into I2, and in this 3 ohms I3 is again in the opposite direction. So 3 into I2 minus I3. So I get one equation between I1, I2 and I3. So that is one. Okay. Then again, like I said, there are two mesh available out here, and we have defined the two mesh currents. We need to equate that, make a relation between those two mesh currents and the current source which is there. So in this case, 5 is flowing from top to bottom. So 5 is equal to I1 minus I3. So you need to write one equation like this. Okay, so as to take this current source also into the circuit analysis. So we have got a second equation. Now the third equation, since we don't have any more independent mesh out here, so we are going to take a super mesh. So we are starting from 10 out here, right? And I1, the voltage across this 1 ohms, which is an I1 minus I2, right? And then we are coming through this 3 ohms, right? And that is again going to be I3 minus I2, because then this I3 is coming here and I2 is opposing it, and then coming here I3 into 1. So I3 into 1, so you get 10. So you get the third equation now. So you have 1, 2, 3 equations, and you got 3 variables, I1, I2, I3. So you can solve that and you get the values of I3, right? You can take a super mesh from outside also, like this from 2 ohms, from 10, from this 2 ohms, from this 1 ohms, and this also. In this particular case, we have taken 10, 1 ohm, 3 ohm and 1 ohm, like this. So one of the super meshes can be taken to get the solution. Okay, so is it clear now? So since there are 3 variables, we need to find 3 equations, one simple mesh, one super mesh, and one equation we are getting by taking this current source into consideration, by taking currents in the 2 adjoining meshes which has got this current source in between them as a common current source. Okay, so that is how we formulate 3 equations and try to solve them. Okay, so that is known as this is known as super mesh concept. And similarly we have something known as super node concept. So when we are doing nodal analysis, we encounter a very similar problem. If you try to write the node equation at V1, it is 5 amperes, right? And then you can write V1 minus V2 divided by 2, that is fine. Then we can write V1 divided by 6 ohm, that is the current which is going into the 6 ohms. But what is the current going between V1 and V2 through this 4 volt? Okay, so that you can't clearly write, right, at this time, at this point of time. So that is where the super node concept comes in. Okay, so whenever there is an similarly, when we are writing an node equation at V2, this 4 volt which is connecting this V1 and V2, they are going to create a problem. So we are going to remove that. Okay. Now it's a very simple concept. See, if you see the current which is at V1, that is the sum of the current which is coming this 5 amps plus the current going into 6 ohm plus these two currents. Okay, these are the two currents which doesn't have any problem, and it's not related with V2 in any way. But there are another two currents which is one through this 4 volt and one through this 2 ohms. Okay. So the current which is going to come through this 4 volt and the current which is going to come through this 2 ohms, they will reach V2, and then what happens? Then it has to come through this 3 ohms and through this 2 amperes, right? So I can write a node equation here, 5 amps plus what is the current through 6, and I can neglect this voltage source and this resistance both together because there is a voltage source which is there between V1 and V2. So I remove all the connections between V1 and V2, 4 volt as well as this 2 volt, both I remove that. Okay, and then I write the current equation here, 5 plus what is going through this 6 ohm plus what is going through 2 and 3. Okay, if I write that, and that is sufficient, because these two currents will ultimately whatever is going through these two branches has to come out from these two branches itself, right? So that is how I write an equation, right? So if I explain you further. Okay, it says V1 and V2 irrespective of the current which is flowing in 2 ohms, it will be 4 volt. So so we are going to remove both these branches here, right? Everything. So we have removed the voltage source which is there from between V and V2, and also the resistance which was there between V1 and V2, and then we write the nodal current. So 5, which is the current going into the VU, is equal to V1 minus 6 ohms. So V1 divided by 6, because this is the potential here is V1. Right, this 0 comes from the fact that what is the potential across 6 ohms. So the potential here is 0 because we have put a 0. So this 0 corresponds to this 0, which is V1 is the potential across 6 at one end of the 6 ohms, and 0 is the potential at the other end of the 6 ohms. So that's why we are writing V1 minus 0. So that is one current. And then since it's a super node concept, we have removed this current source, and we have now shorted these two terminal. So now we take what is the current flowing here. Okay, that is going to be V2 divided by 3, V2 divided by 3 minus 0, V2 minus 0 by 3, and plus this current. So you write this. So you get one equation. That you take an LCM and it is put there. So you get an equation between V1 and V2. One equation you get there, right? And what about the second equation? Second equation, now considering that source. Okay, now from the source itself, what we get? This is positive on the V2 side, right, and it's negative on the V1 side. So it is V2 minus V1 is equal to 4. So V2 is equal to V1 plus 4. Okay, V1 then plus another 4 volts, you get V2. So you get the second equation right here, right? Now if you try to solve these two equations, you will get the values of V1 and V2, and once you get the value of V1 and V2, you can compute whatever currents in there is in each of these branches, right? And you can also finally compute what is the current which will go which is passing through this source also, because once you compute I1, I2, right, and the current which is once V1 and V2 is known, then if what is the current which is flowing in 2 ohms is known, what is the current which is flown in 6 ohm is known, and this is 5 amperes. So some current is going to flow through 2 ohms and some into 6 ohms, and then the rest of the current has to flow through the 4 ohms. So you can compute the current which is flowing in this source also. So essentially in the super node, and we are going to remove that and short these two and write one equation and then we are going to consider like in the it's like same thing which we did for the current. Then there we considered two currents in the loops which had that current source in between. Here we are going to consider the voltage which has got this particular voltage in between. So V1 and V2, we get the second equation. So solving this, we get this equation. Okay. This is something known as super node concept. That is all for today. In Monday's tutorial, I am going to give some more questions on super nodes and KVL, KCL, and super nodes. And in the next class onwards, theory class onwards, we will start discussing about some of the theorems. Okay, and once the theorems are covered, then we will look at inductors and capacitors, like not as a pure element and like you did it in the previous semester, just writing some equations. Because you got to understand the concepts of how an inductor stores an energy. Right, there and then what happens when you're switching off, where does that energy go? We will look at the inductors and capacitors in a more detailed manner, which will help you in designing real life systems in a better manner. Okay, so that's all for today. So next class will be, next two classes will be on theorems, and then we'll start with inductors and capacitors. Okay. Okay, thanks a lot.
Thank you, sir.
Thank you, sir.